Algebra 2, Synthetic Division and the Remainder Theorem, Concept 15, Teacher Talk. So let's hit the highlights of this concept. In this concept, we're working with one process. It's called synthetic division, but this process can tell us many things. In this case, we're going to work 3 different problems using the same process of synthetic division, but each time we're finding out a different answer. So in this first one, it said divide the polynomials using synthetic division. So your keyword is divide. When you're dividing, that means that you want as your answer a polynomial that results when you divide, in this case, our top polynomial of degree 4 by our bottom polynomial of degree 1. So remember, synthetic division, we start by what we are dividing and we pull off the coefficients. We're not missing any exponent terms, so we don't have any zero placeholders. Now also notice, that when you have a division problem, the number that we put out to the side in our synthetic division, it's the opposite sign of what you see, x minus 6. So, and we think in terms of subtraction. What's being subtracted? A positive 6. Now, the way it works, as you remember, I'll just back up a little bit here, is we start by bringing the first number down. We're going to multiply diagonally and then add vertically. So we're adding 1, multiply, add, multiply, add. Now what we do when we're dividing is these are coefficients of a polynomial, and so we start and we fill in those exponents, variables and exponents. And we're going to start with 1 power that's less than what we're dividing. So we're dividing an x to the 4th. So our first variable will be x to the 3rd. So it'll be a coefficient of 1x to the 3rd plus 1x squared minus 2x plus 1. And then that last number is a remainder, and we put the remainder over what we're dividing by. So writing that as our resulting polynomial, it's x to the 3rd plus x squared minus 2x plus 1 minus 6 over x minus 6. Now in Math Excel, it might just ask you for the remainder, and in that case, you would just give the number negative 6. But sometimes, if you express your whole answer as a polynomial, then you can put the remainder as a fraction. All right, number 2, we're using the same process, synthetic division, but this time we're using a different application of it. It's the application of the remainder theorem, which basically says if you use synthetic division, the last resulting number that you get in the process is the remainder, which is the remainder. That's the value of the polynomial when you plug in the number that you're dividing by. So I do notice I'm missing an x squared term, so I'll put in a 0 placeholder. And this time, I'm just plugging in 6. So this is not in terms of dividing by something like x minus 6. I just plug in 6. So we do the process, multiply diagonally and add vertically. And my last number, my remainder, is 181. So that means in my function p, if I plug in 6 for x, I will get 181. And now the third application of this is that you can use synthetic division to determine whether the first polynomial is a factor of the second. So we're going to see if x minus 1 divides evenly into the f of x function. I notice I'm not missing any exponent terms, so I'm going to grab those coefficients divided by positive 1, and remember I bring down my first number, multiply diagonally, and add vertically. What I'm looking at is my remainder, my last number. If it's 0, then that means that x minus 1 did divide evenly into the f of x function. So my answer to this is it a factor? Yes. X minus 1 is a factor of 2x cubed minus 3x squared minus 5x plus 6. All right, that concludes the teacher talk for concept 15, just hitting the highlights.